Good morning. I'd like to talk today about some tools we've been using to study changes in instructor practice as a result of professional development in college mathematics. I want to particularly thank many people who've worked on this effort across the years. Lisa Hassi and Marina Kogan were part of developing the original instruments, which form the basis of those I'll talk about today. Chuck Hayward helped us take a great step forward in turning those instruments from evaluation to research use. Daly and Gallion have coded a lot of observation data. Tim Archie has analyzed survey data, and Tim Weston is the architect of the measurement approach and analysis approach that I'll talk about. So did a lot of the heavy statistical lifting in this project. I'd also like to thank the programs with whom we've collaborated. We can't study professional development in the laboratory. We need real professional development programs to study, and NSF for funding. The problem we'll be talking about is uptake of research-based instructional strategies. We know that these strategies improve learning and students' persistence in undergraduate STEM education, and we know that instructor adoption of those strategies is the big bottleneck in whether or not students experience them. Only about 20% of instructors use research-based strategies in an extensive way. Those are from fairly recent measurements. It's gone up in past years, but it's still got a long way to go before most students experience those approaches in college classes. Teaching-related professional development is widely believed to be a strong influence in advancing uptake of these approaches, but we don't actually have much data about them. Large studies of outcomes of teacher professional development are scarce, especially those that go all the way to the classroom and show that teachers' practices change. There are a few examples in recent years, but not many. In our group, in the variety of studies of professional development, we follow a scheme by Thomas Guskey, who talks about 5 levels of impact in order for professional development to have an impact on student outcomes. First, the professional development experience itself needs to be well designed, well offered, well implemented. We need to know how participants experience it. They need to learn something in the PD, knowledge, skills, attitudes, or beliefs. They need to be motivated and have intentions to implement what they learned. They need to work in organizations that support them to do whatever it is they've been taught to do. That means physical spaces, materials, technology. It means suitable courses and student audiences. We need to know what those environments are. And they need to have the cultural norms around them need to be supportive, colleagues and department heads. The 4th level is instructor practice, and this is where we get to what actually happens, whether it happens, and what happens in the classroom. Instructor behaviors, their attitudes and beliefs, and how those are supportive or not, the changes in these, and instructors' own attribution of these changes to the PD itself. And only then do we get to the point where we can think about or measure student outcomes, such as learning, changes in attitude, grades, persistence. And so you see a lot of things have to happen. There's a long chain of connected events that have to all go well before we can see that student outcomes do improve as a result of PD. So no wonder there haven't been many large studies. In thinking about this work, we use the analogy of the golden spike. The golden spike is the place where 2 railroads, one coming from the east and one coming from the west, met in Utah and joined their tracks up to make one transcontinental railroad. This is a picture of the celebration of that moment. The idea of the golden spike comes from a paper by Urban and Trocum. And the idea is that you measure what you can up to a point where you can then hitch to the research. So here we want to measure the first 4 levels in Guskey's model, and then we tie that to the research that I already mentioned that shows that if instructors teach in certain ways, the student outcomes are better. So we hook on and join to the golden spike at that point. I want to also measure that our group's philosophy has been to focus on instructor behaviors, their actual choices about what to do in class, how to use class time. And we believe that that is the first thing to change after professional development. People try something new. They may not be good at it yet. So we don't want to measure expertise or necessarily quality, or at least we don't rely on quality as the main measure. We want to know, did they change something? And is that change consistent with the thing they were taught in the PD? The key instruments we use that I'll talk about today are two instruments that we've developed from which we call the TAMI, Toolkit for Assessing Mathematics Instruction. The TAMI Instructor Survey probes 11 teaching practices, ways instructors might use class time, such as lecture or small group work. And instructors tell us how often they use particular teaching practices and when they use them, how much class time they use them for. The TAMI-OP is adapted for math from the TDOP and COPUS instruments, which were developed for science classrooms. We saw some different things in math, so we tweaked those instruments. Basically here, the coder is tracking activity codes, which just say, did something happen? Did lecture happen in this 2-minute interval? Did small group work happen? Yes, no. And then they also rate the class as a whole for classroom atmosphere and interactions among students and between students and instructors. These are end of class items that help give us a little broader picture of what's going on. On the whole, this is a behavior focused protocol. It's segmented, meaning it's broken up into intervals, and it's descriptive of what happened here, not how good was it. And the TAMI-IS and TAMI-OP are aligned with each other, and we find that instructors' reports on the survey agree pretty well with the observations in general. The RTOP is the other observation protocol we've used. We choose it because it's a very well-established, often used protocol in K-12 and higher ed. It is a rather different philosophy. It has 5 categories that rate lesson design, the teaching of both disciplinary content and procedural knowledge in the discipline, communication, and the relationship of students and teachers. So it is evaluative, it judges the quality of those things, and it is holistic, judging the lesson as a whole, not broken up into intervals. Just to emphasize the point about the data in TAMI-OP, what we're coding is every 2 minutes, we track what happens. So here's an example. The teacher starts with a bit of administrative work, maybe making announcements or handing back papers. They then start to lecture. They are writing on the board at the same time. They do that for several minutes. Then at some point they stop, and within that same interval, they assign a problem to students that they work on at their seats individually. When that student's work is done, it looks like it's a short problem, the teacher reviews that work and then goes on with the lecture. So this is an example of what the coding looks like. And the point I want to emphasize here is that each of these cells is a data point, a 1 or a 0. Yes, this happened. No, it didn't. There are about 20 activity codes across each 2-minute interval. So we quickly add up to many hundreds of data points to characterize any one class session. So this image communicates what we have to do next. This is where we need to take all that very fine-grained data and we have to make meaning of it. And rather than sort of cherry picking things out of it, we take the whole of them. So I think of each class as a bucket of kidney beans, or coffee beans. We have a bucket of coffee beans, we dump it into the hopper, we grind the coffee, and out comes a beautiful cup of coffee in the end. You can see here that one class is quite a lot of beans, and there's lots of stacks of beans waiting to be coded here in the background. And it's easy to get to hundreds of thousands of data points that inform this analysis. So the beauty of the TAMI-OP is it gets this very fine-grained data, TAMI-OP and other protocols like it. But the curse of it is that you got to do something with all that data. So here's what we do to make the cup of coffee. We use a technique called latent profile analysis. It's a statistical approach that finds patterns of relationships within the code. So there's lots and lots of data, which data tend to happen together in frequent ways, in patterned ways. And so we come up with the latent profile analysis of a large body of observation data previously gathered that gives us 4 profiles. And the profiles are distinct in which activity codes they emphasize and some of their other features. So for example, the four profiles are shown here, plotted across the set of activity codes. The green profile is the didactic lecture profile. That's the nickname for the kinds of classes, the kinds of individual class sessions that have lots of teacher writing on the board and lots of teacher lecture. And they have a little bit of a few other things, but they're dominated by these two codes. And so that's a pattern of association of codes. When you have a lot of this, you also tend to have less of that. That gives that profile its name. And there are many, many classes that fit that profile. A different profile is the one we call group work, which, as you might guess, is characterized by lots of structured group work, lots of this activity code, it's scored high, and lots of this code for teachers moving around the room and guiding the student group work. Again, a little bit of other things, but those are the dominant activities in this profile. A third profile, which is still different than those two, is what we call student presentation. And this one is characterized by a fairly high level of students presenting their own work at the board. It's a common tactic in inquiry-based courses, for instance, and a lot of class time spent reviewing and discussing that work. So teachers are doing things as well, but these are the common kinds of classes that cluster around these particular activities. And finally, the last profile, the one in orange, is kind of a mix of things that we call interactive lecture and review. There's a good amount of use of student work to drive class, back and forth of student work, individual or group, and some shorter lecture segments. So the point here is that these four profiles represent common kinds of classes you would see if you went to visit math classes, and three of them represent flavors of active learning that we often observe in college math courses. And the green one here is the didactic lecture profile, which is also common in college math, and distinct from the more active student-centered forms. So what we get out of that is when we build the profiles and we characterize each video recorded class according to the profiles from the previous, that emerged from the previous latent profile analysis. And then we string the classes together into a course, right? So this is instructor 1 has sent us 12 video sessions. We code them all, and we find that 2 of them fit the didactic lecture profile, 9 of them fit the interactive lecture profile, and 1 fits the group work profile. That looks very different than instructor 2's set of classes or instructor 3. And we calculate as the sort of descriptive variable or dependent variable that we can use in our studies, what we call the P&D, the proportion of non-didactic class sessions. And that is a characteristic of the course as a whole, which is made up of many video recorded sessions of individual classes, each of which is fit to one of the latent profiles. And so the P&D here, for instance, this person had 2 classes that were didactic lecture out of 12, so that means 10 of 12 were non-didactic, and the P&D is 0.83. In contrast, this person had only didactic courses, and so their P&D is 0. All right, so basically all of that data, many, many hundreds of thousands of data points, gets boiled into latent profiles, and then out emerges the P&D as a single number that characterizes that course, that we can use to characterize what happens after PD. So here I'll talk about some data from a set of workshops on inquiry-based learning. We were working with the Academy of Inquiry-Based Learning. They offered 11 workshops on IBL across a 4-year period for about 300 people. The workshop leaders were very well trained. They were expert IBL teachers themselves. They worked in teams. They used a design that was based on research and experience with PD, and they consistently gave very strong workshops. You can see several of the facilitators in light blue t-shirts here in this photograph, as well as Chuck Hayward in the back, observing the workshop. So we have a lot of information about how the workshops went, and they went very well, and there were lots of them. So we were able to collect survey data from people who were part of the workshops. There's a pre-survey, an immediate post-workshop survey, a follow-up survey that is over a year after the workshop, so there's time for people who have implemented something if they wanted to. A subset of 15 of those people participated in the video study, where we gathered video in the semester before they came to the summer workshop, and then a year later. And again, each time we gathered, in this case, a mean of about 9 classes each term, both before and after, and coded those. Again, using both observation protocols, TAMI-OP and RTOP, and our TAMI instructor survey. I've already talked to you about the dependent variable of the PND. For the RTOP, you simply add the rating on each of the 25 items, so you have a score from 0 to 100. And for the IBL, for the surveys, Tim Archie crafted a measure which he calls the IBL frequency. What we know from prior work observing many IBL classes, that the features that are commonly present in those classes, the general practices that are commonly present in those, are student group work, student presentations at the board, and class discussion. Practices that are less common and that drop as IBL instructors implement are lecture and instructors problem solving at the board. So we use the sum with these two in the negative and we add up the frequencies of those on a Likert type scale, and we get a score of -12 to +18 that measures how IBL-ish is this course. Again, based on the practices we've seen in measuring these kinds of classrooms over time. So what you see here are the results from the surveys. The light blue histogram is the survey data before the workshop. The light green histogram shows the survey results after the workshop. So this is how many people reported each IBL frequency score, where more IBL-ish is going up to the right. And what you see here is that there's a really nice bell curve of results. There's a distribution of pre-existing practices, and the whole curve moves up. In fact, the mean moves from about 0 on this frequency score to about 6. So people are reporting more IBL-like practices after the workshop than they did before. We also looked at the survey responses from the subsample, the 15 people who also gave us video data. And those are the people here in the hash marks. This is their pre-data. The slashes going the other way are their post data. And what you see again is they're quite representative of the whole group, both before and after. They fit the same histogram. Obviously, there are many fewer of them, but it shifts the same direction and roughly the same amount. The differences in their survey ratings before compared to the whole group are not statistically significantly different. They're representative of the larger survey group. They're not weirdos. And you can see that their shift is large and significant. And these Cohen's D values are the effect sizes. A large effect size, nearly 1 full standard deviation on both the subgroup and the larger group. I've already talked to you about the PND as our outcome variable. It's a course level variable as opposed to a class level characterization. Again, these are the same 3 instructors that you saw before, their PND before, and now you've got all 15 instructors. And so you can see quite a bit of green, quite a bit of didactic lecture happening before the workshop, as well as a certain amount of student presentation, interactive lecture, and some group work. And afterwards, the profiles for the observed video sessions afterwards show quite a bit less green and quite a bit more group work as well. And so you can see that the PNDs shift. Some people were sort of already, fully student-centered before, in the before time, and were also had a PND of 1 afterwards. Other people shifted more. But you can see as a whole, the group moved. So to summarize the results from the observation and the surveys together, the surveys show a mean effect size, a change in the positive direction towards more IBL-like practice, an effect size of around 0.9. The subgroup who gave us observation data are completely characteristic of that larger group, show a similar shift. The TAMI-OP data, the PND shifts from a mean of 0.58 to a mean of 0.81. That's an effect size of 0.8. In other words, a shift of 0.8 standard deviations. Again, a very quite significant, statistically significant finding. And finally, the RTOP, which is not aligned to these measures, is a different measure of quality, but it also changes, and it changes in the positive direction towards a more student-centered, more interactive classroom, and the effect size is similar in size, in fact, a little bigger even in one. So this tells us behavior is changing, and this tells us in the quality, kinds of lessons are changing in the right direction, the direction desired by the professional developers. So to summarize, using observation to characterize teaching, and especially in our case, change in teaching, is a very powerful tool. It's hard work, it's a lot of work, it's slow, and it's painstaking. It's really important that the instruments align with kinds of changes that are expected. We emphasize the behavioral changes, and that's what we're interested in, and that's what we measure in both of our tools. Using those well-aligned tools, we get quite similar degrees of instructional change after a well-designed TPD experience, right? We see a big shift. It was a good workshop. That's a really great result. And we can show that alignment or that shift is comparable to a well-established popular measure of instructional quality. So things are going in the right direction. We are using similar approaches to study national samples from some other PD programs, Project Next and Project Access from MAA and AMATIC respectively, and the MAA Open Math workshops, which are online summer workshops. And these are very interesting tests for our tools because there's a lot more variability. The IBL workshops were pretty homogeneous and offered by the same set of people over and over, and they were good at it. So here we have a greater mix of presenters, greater variability in the audience, in the workshop goals and delivery, and how much it's focused on teaching and implementing changes. So these give us interesting tests for the instrument and the approaches. Thanks again to NSF for sticking with us for these many years. Thanks to you for taking part and for your conversations. Bye-bye.